In science, we take measurements. And when we take these measurements, we do everything we can to make sure they're the correct measurements. So let's review how to get the correct measurements. So first, every gradient mark, so all these little hash marks, is a known digit. You have to write that down. After you have recorded all the known digits, you need to estimate one more digit. So for example, in this, 142 is known, the 1 is known, and now I'm ready to estimate. Well, it's not a 0, it's not quite a 5. I'm going to go with 4, and the units are centimeters. If you said 3, that would still be correct. If you said 2, that would be correct. The big deal here is you have this, the hundredths place, is your estimated digit. So the question is, which digits are significant? And the answer is all of them. If you bothered to write it down in the lab, it is significant. We call the digits you write down in the lab significant digits or significant figures. So from our previous ruler, our number of 142.14 centimeters would have 5 significant digits. 1, 2, 3, 4, 5. Well, why do we need to know significant digits in the first place? There are 2 reasons. First, we need to be able to recognize the total number of significant digits in a number. You need to know if it's the correct number, and you need to know if you wrote the correct measurement. So for example, if I say, oh, this device will give you at least 4 significant digits, and you only have 3 written down, you know to go back and look at the measurement again. Importantly, when we need to round a calculated number, we will know how to count the number of digits over to the number we need to round at. I know it's a little confusing and we're not quite to math yet, but if we can count sig figs, we can do all the math. So let's re-examine that original ruler. In this one, we have a 1, a 4, and it is right on the line, so I'm going to estimate the 0. On the second ruler, I know the 1 kind of looks like a 4, but do I just leave it like that, 1, 4? You know better than that. It's got to have that 0 to show how big it is. So it's 140, but my estimated digit is the second one, or the tens place, rather than the ones place. Well, which one is right? How do we know if zeros are significant or not? Remember, anything you estimate is significant. So what we need is a set of rules to decide which zeros are significant, and then we can apply them to this situation. And here they are, our rules for dealing with zeros, basically. But let's look at them. First, all non-zero numbers are significant. So if I wrote 152 centimeters, then I have 3 significant figures. I write SF for significant figures. Second, and I like this one, zeros between 2 non-zero numbers. 404. That 0 is significant. So this too has 3 sig figs. These are where you look at those zeros that trail at the end or zeros that come at the beginning if you have a very small number. So a 0 is significant if first it is after a non-zero number. What I mean by non-zero number is not 0. Things such as 1, 2, 3, 4, etc. And here's the part that's important. It's got to be after a non-zero number and meet this other qualification. So one of the qualifications could be after a decimal, and that is after a decimal that is written, not one that is assumed. We don't assume a decimal in science. Or one that is before a decimal. So if we say 150 point, that's 3 sig figs. We wouldn't put another 0 on there. I know you might in math, but you wouldn't in here because that's saying you measured another digit when you didn't. So the example of number 3 would be after a non-zero number and after a decimal. So 4.00 has 3 sig figs, as does, let's see, 0.250 has 3 sig figs. This leading 0 is not significant because it's not after a non-zero number. So really you ask, what's the difference? Why does it matter? It matters a lot. It tells the reader how precise the instrument was that you measured with. So 140, no decimal. 140 point, so with a decimal, and then 140 decimal and another 0. These occurred, or these measurements were taken with 3 different rulers. This first ruler was the one that was 100, 200, and we were estimating the 140. This second one, we had the 100, and then we had 10, 20, 30, 40. So we knew the 140, and then we were estimating that digit, that 0, that it was exactly on the line. So these are 2 different rulers. The last one occurs when we have 140, and then 1, 2, 3, 4, 45, 1, 2, 3, 4, 50. So it occurs right here. We know the 140 because that's written, and then we all are going to estimate a 0.0. So 3 very different rulers that give 3 what we would consider, oh, aren't they the same? But they're really not. So in this first case, there are 2 significant figures. The 1, which is known, the 4, which is your estimate. The 0 is just telling you it's in the hundreds. There are 3 sig figs on this one. The 1, the 4, which are both known, and the 0, which is the estimate. And in this case, there are 4 sig figs. The 1, the 4, the 0, and then the estimated digit. It's very important that you keep track of all the digits you're using and what is significant and what is not. Please place a decimal where it needs to be. Do not confuse these 2 numbers. They're not the same. Look at the measuring devices. This has 150 here, and this is the 140, whereas this one, 140, has its own, and 150 has its own. And there's stuff in between. So this is very, very important. Now let's practice counting sig figs using our rules. So let's start at the top. The first one, there are no zeros here, so all the digits are significant, so there's 3 sig figs. I actually like doing numbers like that. The second one, the only 0 showing is between 2 non-zeros, so rule 2, so according to rule number 2, there are 4 sig figs. Remember, rule 2 states between 2 non-zero numbers. The next one rather, we get into some having to read carefully rules 3 and 4. So we know the 4, the 8, and the 5 are significant. The only thing that's in question is this 0. So let's read rule 3 and 4. First, is it after a non-zero number? Well, yes, it's after the 5 or the 8 or the 4. Any of those count as the non-zero number that it's after. Okay, so now let's read the qualifier. In number 3, is it after a decimal? No, it's not after a decimal. Well, is it before a decimal? There is no decimal written, so it is not significant. So there are 3 sig figs here. And that's, according to rule 4. You don't have to write the rule numbers. Let's look here at this one. We've got our 3, 1, 2, 3, But then let's talk about these zeros. Let's read rules 3 and 4. Are they after non-zero numbers? No, they're not. There's no number up here at any point that's a 1, 2, 3, 4, 5, 6, 7, 8, or 9. Therefore, there's only 3 sig figs here. Rules 3 and 4 both played in here. So let's look at this one. We know this. We know the 5, the 8, and the 4. The 0 between the 4 and the 8 gets in because of rule number 2. So it really is all about these zeros. Well, are they after a non-zero number? And they're not. So it is 4 sig figs. This next one's kind of funny because you got a 4 at the beginning and a 5 at the end. So actually, rule 2 can be used to explain why every single digit here is significant. You can also apply rules 3 and 4, but rule 2 takes care of it. So 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 sig figs. The 405.0. Rule 2 grabs this 0. So really we're talking about this one. Is this last 0 after a non-zero number? Looking at rules 3 and 4. Yes, it is. It's after a 5, or technically it's after a 4. So okay, that meets that one. Does it meet the next one? Is it after a decimal? Well, yes it is. So it is significant. So 1, 2, 3, 4. There are 4 sig figs here. Let's look at this next one. This 0 in the front, does it meet any of these 4? And specifically, we know it's 3 or 4. It does not meet the after a non-zero number requirement. So this one is not significant. The 4 and the 5 are, well, let's consider this 0. Is it after a non-zero number? Yeah, it's after the 5. Or you can say it's after the 4, whichever you prefer. So okay, so it's met half the criteria. Is it after a decimal? Well, yeah, the decimal's right here, but it is after the decimal. So it is significant. So it's 3 sig figs. Notice that on that 0, I said it is technically after a decimal. I mean, it's far after a decimal, but it is after a decimal, so it is significant. Let's go to this next one. The 4 is, we know from rule 2, this 0 is, this 5 is. Let's talk about that 0. Is it after a non-zero number? Yes. Okay. Is it after a decimal? Well, no. Is it before a decimal? Yes, it is before the decimal. So it is significant. So we have a total of 4 sig figs here. Now, we've got a couple things going on with this last one. I'm going to go ahead and bunch this and say, oh look, rule 2, and get those out of the way. So those are all significant. Now we need to talk about the leading zeros and the following zeros. So these zeros in the front, let's look at rules 3 and 4. Are they after non-zero numbers? No. So these are not significant. Let's look at this one. The 0 is after a non-zero number. And then is it after a decimal? Well, yes it is. I mean, far, far after a decimal, but yes it is. So by rule 3, this is significant. So let's count. 1, 2, 3, 4, 5, 6. There are 6 sig figs here. Another example that's important is something like 500.00. How many sig figs are there? We know the 5 is. Well, let's talk about this 0. Well, it's after a non-zero number, and it's before a decimal. It's not right before a decimal, but it is before a decimal, so yes. What about this 0? Well, it's after a non-zero number, not directly after, but it is after. and it is definitely before the decimal. So this one is significant. Let's move on to this 0. This 0, is it after a non-zero number? Yes, it is. Not directly after, but this 5 is somewhere at the front of the line, so the 0 right here is after a non-zero number. And is it after a decimal? Yes, so it counts. Let's look at this last one. Is it after a non-zero number? Yes, it's after a 5. Now it's even further down the line, but yes, it's got a number at the very front, so it is after a non-zero number. And is it after a decimal? It is, because the decimal is right here, and it is technically after the decimal. So in this case, there are 5 significant figures here. When you read this after a non-zero number and after a decimal and before a decimal, be very literal. Is it technically after a non-zero number? Is it technically after the decimal? Or is it technically before the decimal? So be very, very technical when you read this.